Hi, this is Mr. Roix here, and we're going to be talking about neutralization reactions. We talked about a little bit in class. So in a neutralization reaction, basically it is an acid-base reaction. And the purpose of the reaction is to actually have all of the acid and all of the base reacting with each other to form water. So if we look at just a simple strong acid, strong base reaction, if we react hydrochloric acid with sodium hydroxide, they are going to react to form sodium chloride and water. Of course, these things will be aqueous. This will be aqueous. And this will also be aqueous. And our water is going to be a liquid. And if you look at this reaction happens to already be balanced. So when we are determining the stoichiometry behind this and solving for this particular reaction, we're going to notice that, again, the ratio of hydrochloric acid to sodium hydroxide is going to be in a 1-to-1 ratio. So if we had a problem, and the problem was if 25 milliliters of a 0.1 molar hydrochloric acid reacts with 100 milliliters of NaOH, then what is the molarity of the NaOH? So there's two ways we can solve this. So we can solve this using the dimensional analysis that we've used all along, and I will show you the work for that. And as I'm starting to set this up, we're not going to convert to liters. We'll just deal with the milliliters. So technically, our value on top here is not going to be molar, not there, but this should be actually millimoles, and I couldn't erase that. So millimoles. And then we have that, now we solve for millimoles of HCl. The ratio of HCl to NaOH, and again, we don't always have to do all these steps, but I want you to show you how the labels are going to be canceled. So for every 1 HCl, there is 1 NaOH, and that is, again, based on up here, our coefficients in front of HCl and NaOH. They're in a 1-to-1 ratio. And then last thing is we're going to divide by the volume. And if we do that, our answer comes out to be 0.025 molar. And that is the concentration of NaOH. So that's one way to do that. I'll just quickly show you the other way. Without using the dimensional analysis, we can do the same setup. And some of you guys have already been using this in class. It would be using the M1V1 is equal to M2V2. And the reason why we can use this equation is in a neutralization reaction, we want the moles to be equal. And remember, molarity times volume is equal to moles. Well, we want the moles of the acid to be equal to the moles of the base. So if we do the molarity of the acid, 0.1, times the volume of the acid, 25 milliliters, is going to be equal to, we don't know the molarity of the base, but we know the volume of the base is 100 milliliters. And so basically we solve for M2, and if we solve for M2, we're going to get that same value, 0.025. So that's how we solve for a neutralization reaction. So what we're going to do in the next lab is we're going to do titration reactions. So they're basically neutralization reactions. The only difference is we know the concentration of the acid, and we know the volume of the base, and we just have to determine the volume of the acid it would take to react with that base, and that gives us now these three different numbers. So again, we would start with, we'd have a known molarity of the acid, and I say this acid, it could be acid or base, but we know the molarity of one, we know the volume of the other, and then we solve for how much of this is necessary to neutralize, and that allows us to solve for the unknown molarity. And so in the next video that I will be posting, I will take you through how we set up a titration experiment and how we actually proceed with that titration.